Hello, welcome to another video. Today we're going to make a video about making a call. How do you tell from your graphs whether or not your intervention or treatment has actually done anything? So we're going to have a look at a couple little graphs and I'll try and explain it as we go. Okay, so here we've got two graphs. I'll just do a little bit of explaining so you know what they're about. So these are two completely different experiments. One is, you can see on the left, that's about whether caffeine increases heart rate, and the difference between a test where they've not taken the caffeine, measured their heart rate, and taking caffeine and then measured their heart rate again, and what the difference was between those two. The second one is about basketball free throws, and they did a pre-test where they took some shots, saw how many they got in, then did some practice, and then took some more shots to see if that had an impact. And so we'll just talk about these graphs. So this is what we call our box plot of differences. You can see that up the top I've included the summary of statistics. So we've got our median and the upper quartiles, and that's going to allow us to talk about these, about the skew and the spread. So we want to make comments about where the median is, so please make sure you talk about the median, and also talk about the shape of the data. So we can see that the median for the caffeine looks like it's around about 4. If we get like that, so there's around about 4. And if we look at the shape of it, well, let's look at the dot plots first. We've got this big peak here. We've got something at 4 and at 3, and then at 2, and then that drops away. And then there's another little rise up here, almost like a second lump happening up around, I would say that was about 14. So there I'm talking about the dots and what might be happening with heart rates. It's hard to tell. What you can see if we talk more about shape is that the upper quartile is shifted, is skewed away from, so using skew to talk about shape, is skewed away from the median there. So it goes from 4 to 10. That's a big difference, eh? So 4 to 8, sorry. So that's the data for the caffeine. And then if we look at the data for the basketball shots, we can see that there's one. Here's the median. The median is at 0, so it looks like on average there's been no change. That's the mode. There's one big mode, and that's on 0 as well. This is not looking good for the practice and the basketball shots having made a difference. So what we can say then is we need to use this and then start to say, well, what do I think this graph is showing me? Well, in the basketball shots, the mode and the median is on 0. So that's not looking good. We think that might be no change. Whereas you can see that all the values, even the lowest value in the heart rate, was affected by the caffeine. So it's above 0. 0 is not even in the frame. 0 is way away. So it looks like caffeine is fairly conclusively having an impact on heart rate. But we can't just use just one graph, or these two graphs here, the dot plot and the box plot scale. We also need to use the arrow diagrams. So we'll have a look at those. Okay, so what we can see here is our arrow diagrams. Again, let's look at the left-hand side. That's the caffeine. What you notice is you can see all those arrows, they're just flying up. They're all going up on an angle. And because we saw before that everyone improved, so you see all of those lines are all shifting up, and you're looking for that pattern. Can you see that pattern of them all going up? When we look at the other data, we can see actually it's a little bit messier. We've got some that are going up, some that are going down, and it's a bit all over the place. So in order to discuss these graphs to get it achieved, what you need to be looking for is just giving me the percentages. So here, 5 out of the 20 lines start heading down. So that's 25%, a quarter of them have headed down. 7 out of 20, which is 35%, are heading up. And 8 out of 20, or 40%, haven't had any change at all. They've stayed exactly the same. So this is giving more evidence towards the fact that it looks like this practice didn't do anything. If you want to take your conversation a little bit further than just achieved, here's how many went up, how many stayed the same, and how many went down. We can take a look. If you look at the blue line, it starts all the way up in the top left-hand corner, and it drops massively. Maybe you could offer a reason why that might be. So maybe you'll say, well, it's basketball. Maybe they fluked a bunch of shots in that round. But then when they did the real test, they regressed back down to where they should be. So that's probably it's a potential reason why that could be. And if you keep eagle-eyed when you're doing your investigation, maybe you'll see instances of things happening. So make sure you take notes while you're doing your investigation so that you can talk about them in relation to your graphs. So, okay, to wrap up, so when you're analysing your displays, you need to talk about your graphs. You write I notice statements. For a box plot, you're going to talk about shape. That might include modes or skew. You're going to talk about spread, and you talk about the medians, or the median, sorry, and where that is in relation to 0, okay? So 0 being no change. For the paired link, for achieved, you're going to just make sure you tell me how many went up, what percentage went up, what percentage went down, and what percentage stayed the same. Okay, you need to comment on the variables. So what was it about your variables that meant that those what makes a big increase, what makes a small increase. Okay, comment on your experimental design. What about the way your experiment was designed could have impacted on your results? So let's say in the basketball, well, lots of people aren't that great at basketball, and it was quite a hard thing to do. So we had this big change between, it was basically luck whether they got them in each test rather than the intervention or treatment having any say. Communicate your findings. So start by stating your question. Say, okay, my question, I wanted to find out if this caused a difference in this. So answer that. Just turn that from a question into a statement. I found that this causes a difference in that. There you go, done. And then link that back into any research you've done about what you were expecting to find or what was likely. Okay, I'll leave it there. That was quite long. So good luck, and remember, better never stops.